Imagine you are leading the development of a new machine at your company. A system that involves several physical domains such as pneumatics, hydraulics, and mechanics, all working together to provide the required functionality to your machine. You already know that the integration and control of all these systems will be a challenge. But on top of it, the requirements in terms of performance are very strict, and you are not sure yet how you will deliver the right quality without impacting machine and production availability. In order to tackle these challenges, you need a simulation platform that can implement a multi-physics simulation and that is able to connect to your automation system. Combining our virtual controller PLC Sim Advanced with SimCenter AimSim enables you to perform control strategy optimization of a multi-physics system in a virtual environment, reducing the risk during design, operation, and retrofit. Let's have a look at an example. Our task is to optimize a PI controller in TIA Portal. In order to do so, we need a physical representation of our system. The first step is to have a physical representation of our multi-physical system. What you can see here is SimCenter AimSim, and the first step is to build up your model by drag and drop components from the library to your sketch. The next step consists in parameterizing the components. For this cylinder, we need to input, for example, geometry dimensions or the friction of the cylinder. We are controlling how fast this cylinder moves forward by regulating the flow that goes inside of it. This is done thanks to this regulating valve, which has been also parameterized with the pressure drop characteristics. This valve is receiving a command signal from the PLC. We have configured a PI controller in TIA Portal to regulate this valve. We have downloaded this code to PLC Sim Advanced, our virtual controller for the Simatic S7 1500 series. The CPU is already in run mode, and now I need to connect the variables between the simulation and my virtual controller. In order to do so, I need Automation Connect. It's a central interface to connect your simulation model in SimCenter AimSim to the automation system. First, I need to load and connect to my simulation. Then I need to connect to my virtual controller and load the PLC tags that are relevant for my application. The last step is to map the variables between the system by clicking Auto Connect. Now we're ready to start the simulation. I will open the commissioning window of TIA Portal and go online. I will start the measurements for my closed loop control. On the HMI, I'm going to define a set point of 0.7 millimeters per second as the target speed to be reached by my system, and I will activate the speed regulation. What we can see in the commissioning window is the step response of my system. It is a stable response, but the dynamic is too slow for my process requirements. Once the actual value of the speed of my system reaches a stable value, I will start the automatic tuning function of TIA Portal. Now TIA Portal will send oscillations to my system and measure the reaction of my system. Based on this information, it will calculate the new optimized PI parameters. Once the system is tuned, I can go check the new optimal PI parameters in TIA Portal and check once again what is the new system response. On the HMI, I will deactivate and activate again the system response. And in the commissioning window on the right hand side, we can see the new system response of my system, which is significantly much faster than the initial step response without optimized PID parameters. Since I am satisfied with this result, I just need to upload the new PID parameters from the CPU to my TIA Portal project and save my TIA Portal project. In this example, we just optimized PI controller parameters. But with PLC Sim Advanced and SimCenter AimSim, you will be able to analyze any multiphysical process of your machine, for example, oscillation in your hydraulic system or pressure loss. Like this, we can evaluate the influence of the controller on other parts of the system, verify the right sizing of components, and optimize the dynamic behavior of the control system.
Siemens, ingenuity for life.